Okay, welcome to Flipping Physics. Here's what we're going to do today. We're going to learn the kinematic equations that are usually in the physics book under chapter 2 after the intro stuff is over. And they're quite easy. The first one is the average speed or velocity. We're going to learn that velocity has a direction and speed doesn't. Speed's just the magnitude. So for now, let's pretend we're going in a straight line and we're not turning. And so that speed and velocity will have the same value. Okay, we'll talk about this later on when they really mean something totally different. This change or average speed is equal to a change in position over a change in time. Now, a lot of times when you see equations, they don't put the little triangle next to the time. What does the triangle mean? The triangle means change in. It's the Greek letter delta. So a change in position means that I start here, this is x initial, and then I maybe drive east, and I end up over here at x final. Do you see that the displacement would be delta x, x final minus x initial. So that's what the delta means. Now, the time over here was t initial, and the time over here was t final. So you can see that the average speed is effectively the total distance over the total time. So when you see a line over the top, that's average. Average speed is total distance over total time. Now, if you're going in a straight line and you start here and you end up here, then the displacement is from here to here, and it's like 5 meters east. But the distance is just 5 meters. So you don't have much of a difference as far as number-wise if you start here and end up here in a straight line. What happens in previous or other chapters is you're driving and you're going over here, and this is your distance. And you end up here. So here's x initial, and here's x final. And the distance you traveled is like the odometer reading on your car. You don't know where you went, you just know how far you actually traveled. But the displacement is a vector from the starting point to the end point with direction. So you see how the numbers are going to be totally different than if you actually just kind of knew what you did travel-wise compared to the displacement. Totally different answer for the whole thing. Okay? So there's a big difference between distance and displacement when you're talking vectors and you're talking about moving not in a straight line, but in maybe a curved path or two different straight lines added together. But for now, let's just talk about one-dimensional motion. So the only thing you really can do is go here or go backwards the other way. And the only trouble we're going to get in it, if you start here and you walk 5 meters east, and then you walk 3 more meters east, your displacement is 8 meters east. 8 meters east. Okay? But if you travel 5 meters east, and then you turn around and you go 3 meters west, you add vectors by putting the tail of one on the head of the other. Just like I did here, here's like I did here. The answer is 2 meters east. You see, now we don't agree. 8 meters equals the change in distance. All right, but 2 meters is the change in displacement. So a little arrow on the top tells you it's a vector. Okay, so we're gonna get into more detail with that stuff when we talk about two-dimensional motion. But for now, I just wanted you to know what these terms are. So when you see a triangle, it means change in. It always means the final whatever minus the initial whatever. Okay? So if you see a delta V, it's the final velocity minus the initial velocity. Okay? If you see a delta T. Now, here's a shortcut you'll see when you read the book. A lot of times, they skip the delta of the delta T. and they just write T. I hope that doesn't bug you, because delta T is T final minus T initial, but what's usually T initial every time you start your clock? Usually T initial equals 0. So a lot of times you'll see these equations where you just see T. Don't think T is an instant of time. It's still an interval, it's just that this was 0. Everybody okay with that? T final minus 0. So sometimes they just drop the whole delta on the T. So if you see this equation, V average equals delta X over T, don't let that bug you. Okay? And if you see that equation, you could do the algebra and rewrite that. Why don't you solve for X final with this equation? That would be awesome. What do? You multiply both sides by time and move the V X initial over. So I'm skipping some steps here. Try it on your own if you need to pause the video to do it. But show that you know how to get that equation equals that equation. They're the same. Okay? And we're going to affectionately tell you that that's equation A. Equation A is the definition of an average speed. Okay? Let's get rid of all this stuff. And move on. So, the definition of an average speed is the total distance over the total time. It's the total over the total. How long did it take you to go a certain distance? Okay? And you could rewrite this as X final equals X initial plus V average times T. Notice that's really a delta T, but I'm writing it as T because T initial equals 0. Okay? So let's try a few, just to see if you understand things. Let's say you go 12 miles in 2 hours. 12 miles in 2 hours, the average speed is 6 miles per hour. It doesn't mean you're always going 6 miles per hour, but the total distance was 12. In the total time of 2, 12 over 2 is 6. So 6 miles per hour is the average, but you may have been going faster or slower at different times, but it came out to be the average speed. So even if your acceleration is constant or the acceleration is not constant, this equation is still valid. Total distance over total time gives you the average speed. So you can find something out even if you don't know other stuff like what happened at 2 o'clock. Okay? All right, let's try another one. What if you have, my mom lives in Niagara Falls, that's 90 miles away, so delta X equals 90 miles, and let's say it takes, time is 2 hours to get there. I stopped for a break and hung out, got stopped by the cops because I was going too fast, and you get 90 miles in 2 hours. So what's the average speed? 45 miles per hour. Okay? Now, that's a great example. I mean, like, the difference between an instantaneous speed and an average speed. Let's say I'm driving at 90 miles per hour. Every time I look at my speedometer, I'm going 90 miles per hour. Okay? Every time I go, I'm going 90 miles per hour. What is that I gave you? Every time I look at the speedometer, it says I'm going 90 miles per hour. That would be the instantaneous speed. That's how fast it's going right now. Okay? And my mom lives 90 miles away. So how long would that take if every time I look at my speedometer it's going 90 miles per hour and it's going 90 miles away? How long does that take? Well, hopefully you know how to do this and realize that 90 miles per hour, delta X is 90. 90, do the algebra, flip and multiply, and 90 divided by 90 gives you 1 hour. So it should take you 1 hour. So why did it take me 2 hours? Why did it take me 2 hours? Why was the average speed 45? Well, I was going 90 miles per hour when I looked down at my speedometer. I was going 90 miles per hour when I passed, the amusement park on the I-90 in Western New York. I was going 90 miles per hour when I passed the bushes with the cop in it. Every time I looked, I was going 90. When I saw the blue lights flashing in my rearview window, I was going 90. And so I was going 90 every single time. So why did I average 45 miles per hour? And the answer is because it took 2 hours. Why did it take 2 hours? Because I was stuck there while the cop was checking out my license and registration, and he held me there. Then I got all upset, so I stopped at Tim Hortons for some coffee after that. So the point I'm trying to make here is the instantaneous velocity is different than the average. The average is the total distance over the total time. But every time you look at your speedometer, you might be going 90. But your average might end up only being 45, depending on your speed overall. Total distance over total time gives you the average speed of the thing. Okay? So this equation is really elegant, and it is the basis for a whole bunch of stuff, and it's used all the time, but sometimes it's abused. And I'm going to show you an example of when it is abused. I'll show you right now. Let's say I went to Niagara Falls and I went 90 miles, okay? That's delta x1, we'll call it. And I went 90 miles, and let's say I was going at an average speed there, 90. I really was cruising. I went 90 miles per hour for the average speed. I got to my mom's house, right? And when I came back home, I went 90 miles again, right? To get back home, 90 miles. And this time, because I got stopped by the cop, I averaged 45 miles per hour. So, on the way there, I went 90 miles, and I averaged 90 miles per hour. On the way home, I went 90 miles, but because I got stopped by the cops, my average speed was 45 miles per hour. Okay? Let's pretend I was going a constant speed of 45 miles per hour. Forget the cop, just say I was taking my time because I was scared. Let's say I was going an actual speed of 90 miles per hour the whole time. So I went 90 miles per hour for 90 miles. I went 45 miles per hour for 90 miles. Here's the question. What was my average speed for the total trip? What was my average speed for the total trip? Okay? Now, this is where I want you to stop the video. And I want you to actually figure out what the average speed was for the whole trip. So right now, pause the video and figure that out. Okay, we're back. Man, I hope you really did pause the video. You could watch videos and get entertained by video, but not learn a damn thing. I mean, that's like watching pro football on TV and then go, okay, I'm ready for the NFL. That's like watching me weightlift and go, oh yeah, now I can bench press. I watched Hortense weightlift. It doesn't work. Pause the video if you haven't and actually figure out what the average speed. Okay? Now, here's what some people do. They say the average speed is 67.5 miles per hour. And how do they do that? They did 90 plus 45 and divided by 2. Okay? They took the average speed. Here's the average speed on the way. Here's the average speed on the way home. So the average speed overall is 67.5. Nope. It is absolutely not true. Okay? You're making up formulas that don't exist if you do that. This formula doesn't exist. You might think it existed because you saw something similar in the book, but you can't do that. This is a constant speed of 90 and a constant speed of 45. So the only way to get the total trip average is to do the total distance, what's the total distance? 90 plus 90, or 180 miles, and divide by the total time. What's the total time? Well, you have to use this equation, in your head maybe, to figure out the total time. Isn't T1 on the way there 1 hour? And isn't T2 over here 2 hours? If you don't know how I got 1 hour and 2 hours, try it with the equation A and see if you don't realize that that's how much time it takes to go 90 miles at 45 miles per hour. So the total time is 3 hours. So the only real equation you can use is to get the total average speed for the whole trip is 180 miles over 3 hours, or 60 miles per hour. Okay? Don't use equations that don't exist. We got plenty of them. We don't need new ones that don't work in this universe. Okay? So, here's the example I give. If you got a 90 on one test and 45 on the other test, your average would be 67.5 if you had two tests. But you're going 90 and you're going 45 for twice as long, so it's like you had 3 tests. And if you add these guys up, you got 180, and you divide by 3, and you end up with 60 as your average. So because you spent more time going 45, the average is moved over, not 67.5, but down to 60. Okay? Is that interesting? All right, so let's start over and write that first equation down. That's equation A, delta x over delta t. Now, back to vectors. If I went to my mom's house and then I came back, what would be my average velocity? That would be the total displacement over time. And that would be 90 minus 90, west and east, means my displacement's 0. So my average velocity is 0. Most people don't even bother asking you for average velocity because sometimes it's 0 and you don't really learn a thing about average velocity. So average velocity is not something usually people ask about. They usually ask about average speed. Okay? So there's the equation A. Let's label that equation A again. And let's write that other form one more time. Okay, now, you guys are in calculus space, so we can rewrite this thing as velocity instantaneous. Velocity as a function of time. How fast am I going at that instant of time? And then you know in calculus class that it's really the limit as delta t approaches 0. In other words, we're getting this average, we're getting the time interval down, so it's not 3 hours, it's not 1 hour, it's not a minute. It's the time it takes for me to just look at my speedometer. So it's the amount of distance you travel, which might be a nanometer, in a picosecond. It's a tiny amount of time, so there's only a little distance traveled in a tiny amount of time, and you still might end up with 90 miles per hour as your speed. When I look down at my speedometer, I'm getting my instantaneous speed. Okay? So in calculus class, you learned that you can write all this in a short version, dx dt. So that would be the instantaneous speed. Equation A is the average speed. All right, so that's the definition, and that's pretty much everybody I wanted to talk about with the equation A. If you're trying to memorize these equations and you seem like it's a little overwhelming, just realize equation A is just the measure of average speed. The second equation is the definition of an average acceleration. It's change in velocity over change in time. Okay? Some people drop the delta on that one because they know it's still a time interval. You could rewrite this with algebra. Make me proud. V final equals V initial plus A times T. And if it's not a constant acceleration, average acceleration. Just like we did the algebra here, we can do the algebra here and get another form of equation B. There it is, equation B, equation A. So the first one's the definition of an average speed. Second one's the definition of an average acceleration. What the heck does acceleration mean? It means you're changing how fast you're going with respect to time. You want to know how fast you're going after 3 seconds? And you are accelerating at 3 meters per second every second. You'll go 9. You'll go 3 meters per second after 1 second. You'll go 6 meters per second after 2 seconds and 9 meters per second after 3 seconds. Okay? If you start from rest. Isn't this a beautiful equation though? So here's a simple little question. What if you were going 15 meters per second? That's the metric way of describing speed. Okay? 15 meters per second when you started the clock, right at t equals 0, it was 15 meters per second, but then you're accelerating at 3 meters per second every second, or 3 meters per second squared, the shortcut way of doing that, and you decided to do that for 4 seconds. So you used to be going 15, but now you're going 3 more for 4 seconds. Every second you add 3. So try it on your fingers. After 1 more second, you're going 18. After 1 more second, you're going 21. And then you're going 24. And then after 4 seconds, you're going 27 meters per second. So 27 meters per second is how fast you're going after 4 seconds if you start at 15. Beautiful equation. And that will have a bunch of little questions you could answer on using that equation. But right now I just want to introduce the equations, and that's equation B. Equation C is so lame, some books don't even have it written down. It's V average again, is equal to V final plus V initial all divided by 2. In other words, the first equation is the average speed, second equation is the average velocity, and the third equation is average anything. What do you do to find an average of things? You add them up and divide by the number you do it. Some books don't even have that written down. It's so lame. Okay? But I'm going to write it down and I'm going to call that equation C. Okay? Now, here's when this equation can't be used. That sample I gave you, if you got that wrong, you used this equation illegally. Don't use this equation unless A is constant. In other words, you're going from one speed, V initial, to the final speed, V final, at a constant acceleration. If the acceleration is constant, you can use that equation. Okay? So if you're starting at 15 meters per second, and that's VI, and you ended up at 27 meters per second, and that's V final, and the acceleration was constant at about 3 meters per second squared, yes, you can use this equation and find the average speed. And that might actually be an easier equation to use than doing total distance over total time, because you'd have to figure out the total distance traveled with those two speeds in order to get that right. Okay? So sometimes equation C is a better one to use, but never ever use it unless acceleration is constant. Promise? Okay. Now, there's 2 more shortcut equations. I could algebraically combine A with B and C, and if I combine them, I can get equation D. And equation D is X final equals X initial plus V initial times the time plus 1/2 the acceleration times the time squared. This I'm going to call equation D. And you should be good enough at algebra to know how I got equation D from equation A, B, and C. All I did was combine the 3 to get equation D. Okay? All right. So forget I told you equation D for a minute. And let me just try a question. Let's say I start from rest. When you hear the start from rest, it means I wasn't moving. And I accelerate at 3 meters per second squared for 4 seconds. How far did I get? I'm going in a straight line, so displacement and distance are the same thing. I want you to notice what I did. I made a list of everything I know, and then I put down as a question mark everything that I need, and now I find a formula. Now let's have some fun. Let's pretend you didn't know equation D existed. Ignore that for a minute. Look at equation A, B, and C. How would I find how far? What's the only equation with how far in it? What's the only equation with delta x in it? Right now, hopefully, if you're playing along with me, you used equation A. It's the only one with a delta x in it if you ignore equation D. So, all I got to do to get how far is how fast, average-wise, V average, and the time. I got the time. So all I really got to do is know the V average. Great. So what's V average? I have an equation for V average over here, equation C. So all I got to do is use equation C to get V average. All right, here we go. V final plus V initial over 2. Uh-oh. I don't have V final. So I don't know how to get V average to get the answer. Delta x equals V average times T, but I don't have V average. So what's V average? Well, I don't know V average, so I use equation C. But equation C, I need V final. So I need V final. Even though nobody asked for it, I need V final. So what equation would I use? Well, wait a minute. Equation B has V final in it. Look at this beautiful form. 0 plus 3 times 4. So what's V final? 12. If V final is 12, and I started from rest, use equation C now, and what's V average? V final 12 plus 0 over 2. So that's 6. So V average is 6 meters per second. So nobody asked for this, but I needed it. To get V average that nobody asked for, but I needed it in order to get the answer. And so the answer is 6 meters per second V average times the time, 4 seconds. That's delta x. So how did I find delta x? I used equation A, but I combined it with equation C to get V average, which I needed to put equation B in there to get V final, to get V average, to get delta x. Oh, I had to find 2 things nobody asked for, but the only equations I used were definition of an average speed, definition of an average acceleration, definition of an average anything. Okay? If you algebraically did that without knowing this question, you would get equation D. Try that for homework. Try to get equation D algebraically by just combining A, B, and C. Do what I did with numbers, you do with letters, and you'll get equation D. So let's try equation D. It's a shortcut. You don't need it. You never have to use equation D. But if you don't want to find things you don't ask for, if you're in a hurry, equation D is a beautiful shortcut. So here's equation D. Let's try it. Delta x, that's this minus this, equals V initial, 0, times time, 4 seconds, plus 1/2 times 3 times 4 seconds squared. 4 seconds squared is 16. 16 times 1/2 is 8. 8 times 3 is 24, which ends up giving you the same distance as 6 meters per second times 4, 24. So it's a shortcut, folks. It's something that you can use to get the answer if you don't want to find stuff nobody asked for. Okay? All right. So if you algebraically combine, you can get yet another shortcut equation. So let me show you why they came up with yet another equation. It seems like people who learn this stuff get a little overwhelmed because they got all these equations. But I'm trying to make it so it's very manageable for you. Let me explain what I did. First one's the definition of an average speed. Second one's the definition of average acceleration. And the third one is the definition of an average anything. Those are the only ones you need. That's not overwhelming. You can almost memorize it now by just knowing that, miles per hour, distance over time, average speed. Acceleration, meters per second. Average anything, add them up and divide by 2. So that's not overwhelming. So equation D is a beautiful shortcut, and I hope you use it as much as you can when applicable. Let me give you another question where you kind of fall into some trouble. Let's say V initial is, let's see, how fast were we going before I erased that thing? Remember I went from, what was the final speed? 12? 12 meters per second. Okay? V, well, that was V final. V final was 12. V initial was 0. Okay? And the acceleration was 3 meters per second squared. Now look and see what I just gave you. If I gave you the final speed, the initial speed, A, and I'm asking you for how far did it go, I did it again. I made a list of everything I know. I made a list of everything I need, and then I need a formula. Okay, now let's look at the equations and see, well, there's only one equation with a delta x in it, so I still got to use delta x equals V average times t, but my list doesn't have V average in it, and my list doesn't have time in it. So I got to find two things I don't want to get the one thing I actually was asked for. So how do you find V average? Equation C. V average is 12 plus 0 divided by 2. So V average is 6 meters per second. How do I get the time? The time I can get from equation B. Change in velocity is 12. Divide by 3 is 4 seconds. So again, I'm doing that, but what did I do? I used equation C to get the average speed, and I used equation B to get the time, and I combined them together into equation A. So again, I used equation A, B, and C, but this time there was no time. So if you algebraically did that, and you did that with just letters instead of numbers, you would get another shortcut equation, V final squared equals V initial squared plus 2 times A times x final minus x initial delta x. And that, folks, I'm going to call equation E. And when do you use equation E? When would that be an awesome time to use equation E? When you don't have time. So look at the list you make when you do these problems. If they didn't give you the time and they didn't ask you for the time, so you don't care what the time is, try equation E first. That's the one to use when there's no time. If you're looking to see how far and they did give you the time, bet you equation D will really help. If you want to know the final velocity and they gave you the time, use equation B. If they want the final velocity and they didn't give you the time, use equation E. Is that nice? It's very manageable now. Hopefully these 5 kinematic equations make really good sense to you and you're able to do all those homework problems based on kinematic formulas. Okay? So, for homework, you should be able to algebraically get those two together.